So now for our last presentation of this session, we'll have Anthony Jennings from the University of Utah telling us about different methods and tasks that we use touchscreens for.
So this was the bio they were supposed to say when introducing me for my presentation today. I'm happy to introduce Anthony Jennings, who is representing the University of Utah in his research on touchscreen devices and the effectiveness of user interface methods. Anthony Jennings, Tony for short, was born and raised in Salt Lake City, Utah, where he recently graduated at the University of Utah with a certificate in human factors. Since graduation, Tony has moved to Houston, Texas with his wife and 2 dogs. Tony still maintains contact with his human factors professor, Dr. Frank Drews, and is already planning on furthering the research he is presenting today. Although he began programming as a teenager, Tony has worked as a computer programmer and database engineer for 7 years. Tony's initial interest in programming came with the desire to exploit design flaws in a video game to gain an upper hand. As a hobby, Tony has written and maintained several mobile applications on Android. Today, he celebrates one of his apps having been downloaded by more than 100,000 people. While Tony enjoys programming, his true passions have always been psychology and problem solving. He is grateful to have recently discovered human factors and feels right at home. He loves his job and hobby as a programmer, but looks eagerly to the future opportunities in this field.
Wow, thank you. I didn't really know what to expect in these meetings. There's a lot more people than I thought there'd be, but I'm excited. I really enjoyed the presentations thus far, and I think a lot of the questions that have been asked, maybe some of the ideas we've been tossing around can maybe partially be addressed through my presentation. I was thinking about perhaps the preference towards a larger screen on a mobile device. So I'm representing the University of Utah and my team down there. I'm Anthony Jennings, and Spencer Renser and Frank Drews, our professor. So we're going to be looking at touchscreens specifically. We're going to be looking at tasks that are performed on touchscreens, scrolling and zooming. So why is this important? We've kind of already talked a lot about this today, so I won't beat a dead horse with this, but some interesting statistics. 50% or 56% of adults own a smartphone. If I were to ask that in this room right here, I think we'd have a bias, but raise your hand if you have a smartphone. Okay, yeah, so we have a bias here. It's a bit more than 56, but also there's 75% of people under the age of 43 own a smartphone, and we're told that it's estimated by the end of 2013 there will be more mobile devices manufactured on this earth than there are people to use them. And just looking at Android devices alone, there are over 12,000 different models and varieties. So we're starting to see a lot of different models come out, a lot of different variety, and with that there's a plethora of development. There are over 2 million apps combined across some of the major operating systems. And each one has its own user interface. They'll take advantage of certain similar tasks like scrolling or zooming. Those are pretty common tasks that you're going to see all throughout these different apps. But it's creating a lot of confusion, I think. But of those 2 million, 4 of them are mine, or 6, I guess, if you want to count 3 versions. So I'm an Android developer, and for our research, I actually developed an application on Android phone and Android tablet. And our goal of the study, independent of which operating system it is, was to identify which methods produce the least amount of errors, time, and effort in scrolling and zooming. Also, we wanted to try to answer whether certain methods are better suited for different screen sizes, phone size or tablet size. So in our research study, we had 56 participants, students at the University of Utah, both male and female, average age being 22 and a half years old. And the average participant owned about 2 touchscreen devices, and they had about 3.5 years of experience using a touchscreen device. So as they came into the experiment, we would randomly assign them either a phone or a tablet. And then they were also, of course, everything was randomized. They were assigned 4 different methods for scrolling and 4 different methods for zooming. And we'll take a look at what those methods are in just a moment. And then for each method, they were required to repeat their tests 20 times. So with scrolling, they were randomly assigned, their task was kind of randomly assigning them different image sets. So they could have been assigned either animals or electronics. There's some examples there of them. And so there's 20 different images. And they would be presented with one image. So take, for example, the elephant. And so they'd be shown this image and asked to scroll through the remaining 20 images and find that elephant and click on it. So that was the task for scrolling. And then the different methods they had available to them for scrolling were arrow buttons that would navigate them left or right. There's the standard traditional flick that we're used to on our phones where we, oops, I went back. Go back. Okay, so there's the flick where we slide our finger, and then a navigation bar down here at the bottom, which is similar to, it's similar to the one above, left and right, but then it's got the button for first and the button for last on the left and right there, and then the scroll bar where you're just using the actual bar to scroll with. Next, with the zooming task, they were randomly assigned to either begin zooming in or begin zooming out. And they're instructed to zoom the image, the blue box, to the size of the white box to match that up. So the size of the target white box would be randomized in each iteration they would do, so they'd have to scroll to several different sizes. And the different methods we applied for zooming were just simple zoom in, zoom out buttons, plus and minus there. And then the pinch and spread that you're used to on your mobile phones probably. And then the toggle button, which was you select the mode, either zoom in or zoom out, and then you tap anywhere on the screen and it zooms in or out, depending on which one you have selected. And then there's kind of like a track bar where the closer you are to the plus or the minus, the more it zooms. So those are pretty common methods that we found being implemented on touchscreen devices and also on other user interfaces. And so we're going to take a look at the results now, but just from a general high level, kind of what we found is people were faster on phones, but the effort required to do the task was much more on the phone. And we'll talk about how we measured effort as well. So tablets would take a little bit more time, but it's reduced effort for the user. And the error rates were pretty much universally the same, regardless of if you're on a phone or a tablet. So diving a little bit deeper now, we looked at 3 measurements: time, error, and effort. And I'm going to explain this graph once, so that makes sense because they all kind of look the same. But going vertical, we have our measurement. So in this case, it's the time that it took to complete the task. And then the horizontal, we have the different methods that we implemented. And the light greenish color there is the phone, and the purplish color is the tablet. So we found a significant difference between methods, indicating that there was obviously certain methods are faster than others. And there's also an interaction between devices and method applied, indicating that phones in this case were faster on all of the different methods as compared to a tablet. I want to pick on Flick a little bit because that's the most commonly used that we see today. And I just wanted to pick on it because it was the slowest. And it just has very little performance difference, regardless of the device. And that's key. I think maybe that's why we use Flick the most, even though it takes much longer. It's pretty much universal about how much time it takes, tablet versus phone. So just to point out a few more significant findings we found there, the ones with the stars indicate an additional significance that we found. And we found that these 3, like I basically just mentioned, were all significantly faster on the phone versus tablet, whereas the Flick, that was not a significant difference, even though the average was quicker. Regarding errors, in their 20 attempts, they pretty much all averaged about 1 error across the board. So there's an absence of any main effect or interaction there, and difference of screen size doesn't really appear to affect the number of errors committed on scrolling. Regarding effort, okay, now I mentioned I was going to explain how we measured effort. This is really hard to do because when you're looking at different methods, what you're doing with your hand may be completely different. So how do you say it's more effort? Well, what we looked at was to complete the task, scrolling, what was the minimal or optimal amount required to scroll. So if you're using the arrow buttons, that's really easy. You had to click the button 4 times to find the target, or 5 times. So anything exceeding what was optimal or the minimal was what we measured as the percentage. And so that can be applied universally to scrolling. Essentially what we're capturing for effort is over-scrolling, or I guess there could have been under-scrolling as well. So these percentages you see, 0% would have been if they did exactly what was optimal to arrive at their target. So the main effect we find on the device was just really that there's higher effort spent when using the phone. There's a significant main effect of methods indicating differences amongst scrolling method and performance. And I want to pick on Flick again because even though it took longer, users were less likely to exceed what was optimal. And I think we'll talk about that later, but I think it's because they're just so sick of scrolling that they don't want to over-scroll. They just want to find it and be done. So again, additional significant findings. We found that the navigation bar and the scroll bar were significantly more effort on a phone versus a tablet. Flick and arrow buttons were not necessarily significant, although the averages were lower. So now to zooming, again, we have our measurements on the left, just like we did with scrolling. So zooming times is what we're looking at right here. And we find a significant effect indicating that phones, again, are faster in zooming. And a main effect identified by the methods indicating certain methods were faster than others. I'm picking on the pinch and spread because also that's one of the most commonly used methods. And although it is not, we didn't find it to be significant, on average it did take longer than any other implementation. An additional significant finding we found here was that the buttons were faster than every other method, just simply zooming in with the button, zoom in or zoom out. The errors here were kind of interesting. There's no main effect of device, so it doesn't matter. You won't make more errors on a tablet or a phone. But what you will find is that you make those same errors on the method. And obviously pinch and spread is the major culprit here. So we found significant errors with pinch and spread where it was significantly more. 6 out of the 20 times they would zoom in or out would be wrong on average, or the wrong size, and they just give up and submit it. And then the next worst culprit was the track bar. And the buttons were superior on that. So the effort, again, that's the percentage of going over what was optimal. Again, we see kind of the same thing here, where it's indicating higher effort required for certain methods, and there's really no main effect of device on this, although the tablet seems to be more efficient. And then we did find significant findings with the track bar. The buttons required the least amount of effort overall, least amount of effort, and they were also the quickest. And then the pinch and spread we found was only significantly better than the track bar, statistically significant, I should say. So let's move on to the discussion. We found 3 major findings, and I think there's probably more than what we have up here as well, and there's certainly more that could be analyzed of the data we collected. But it's kind of, I keep saying that it's providing science to what seems like it should be common sense, but user interface design should consider the task and the screen size. So you've probably seen this if you have a tablet and a phone, where you have the same user interface for your tablet as you do on the phone, and it just doesn't work. And I think that that needs to be considered when you're designing your user interface. And also from our study, we found no statistical relationship between time and accuracy. Instead, what we need to strive for is to find the balance between the time and the effort that's being spent. Also, there's a negative inverse relationship with the screen size. Increased screen size means that you're going to take longer on the task, but it will be more efficient. It will require less effort of you. And I think that might be maybe answers or suggests why people are kind of trending towards these larger devices for their phones. It might take them a little longer to do something, they can't reach as far or whatever, but maybe it just requires less effort for them visually and technically. So the other thing I wanted to point out was, although it's kind of the standard today for flick, fling, and pinch and spread, possibly they're not necessarily the most optimal or efficient, effective implementation. You really have to look at what your application is doing and what you want your users to be doing, and then kind of balance that out. Because even though it's the most familiar, it's not necessarily the most optimal. It's drastically increased time and, like I said, the effort. Here's one interesting point about the pinch, spread, and the flick and fling, is that although they appear to be lower effort, if you remember scrolling, it was one of the lower efforts, and the pinch and spread was there. It actually requires the most physical effort, demanding. And we don't necessarily have data to support that other than several hours of watching 56 participants getting really frustrated. We have their comments, we just haven't analyzed them or averaged them out yet. You could tell that they were getting exhausted as they were doing the pinch and spread and the scrolling. It just was a little bit tedious. So with that, I guess we'll, if there are any questions, and my contact information is below if you want to contact me personally about the research or about Android development or app development. Let's go with this gentleman. You raised your hand first, Andy.
I was wondering, you mentioned something about certain types of apps you might, or what I was taking from it, I guess, certain types of applications you might be able to use a pinch and zoom or a flick. It may be more appropriate in certain types of applications. When you were talking about the pinch and zoom, I guess I was thinking of math applications. And would that be more usable if there's maybe another interaction you're doing, like in a math program where you're pulling the math around and possibly zooming in and out?
Yeah, I think I see what you're doing at. I think what you're talking about is panning, left or right. We specifically wanted to keep it simple in this study, to just simply do zooming, because there is that complexity of panning. There's lots of different ways to implement that. But I think really what we're getting at is our task measured them being able to adjust the image at a certain size, right? So if you're thinking of a photograph of someone, it maybe doesn't matter if you get it to a precise size. You can just kind of spread it how you want it with your fingers, and you just want it to zoom in really quick. Maybe that's a better kind of implementation for that. But if it's something where it needs to be precise, something needs to be zoomed in at a precise level, you probably really don't want to go with pinch and spread, because you're sitting there trying to make these micro movements to adjust something. The gain is not very great. Gentleman with the amazing mustache.
A comment and a question. So one, I would encourage you to assess the physical interaction between your different methods. And you make this conclusion that perhaps we have to consider different types of interaction across devices. And I'm wondering if you're considering how to factor in the disconnect between how I transfer now for one device. So if I have different ways of doing something on my phone and a different way of doing it on my tablet, there's a cost associated with that for the user.
Yeah.
And how do you factor that into determining whether your conclusion is really valid?
Well, I mean, I think there's kind of more to your question than I can answer, but so much of it has to do with differences, right? Like, I don't know if your question's really getting at, well, am I switching from my phone to then my Android tablet? And then what does the developer have to do across those devices to make it the same? Or were you kind of just saying, from looking at a task-oriented perspective, are you saying, what do I as a developer need to do so that when I'm scrolling, it's universal across the devices? Or could you explain your question maybe a little more?
Yeah, so what I took from your conclusions, you're saying on a phone to do a particular action, you might say, I'm going to press a button, right? But then I might do on a tablet, I might do a scroll bar or a flick. And so then within the same app, that interaction is going to be different on the phone than it is on a tablet.
Right.
And as I transition from one device to the other, there's a cognitive cost to that disconnect.
Yeah, I agree.
And how do you factor that into your research?
I don't know if I have an answer or a recommendation really yet. I think you're right there. You do want it to be a similar transition, but you've got to weigh really, I think the task of what you're doing with the design of the user interface. Maybe your task doesn't need to be on a tablet and a phone, even though we like to have it universally. Maybe if it's better suited for a tablet, you just design it for that, or vice versa, I don't know. But that's a really important thing to consider. You, sir?
Curious if you have an opinion on the proximity sensing fingertip devices, if that's just going to change all this, is it a game changer? Do you see an impact there?
I don't think so. I mean, we use different devices, but we're getting into really nitty gritty. I mean, like I was even getting into, okay, when I was looking at this originally, I was looking, okay, well, how many dots per square inch or whatever am I going to have to account for this in my research as a limitation, because the tablet maybe has a more sensitive screen than the phone. For the research that we did, that just wasn't applicable because there wasn't really that level of precision required. Zooming or scrolling was one-to-one, and pressing the buttons, they were large enough for their fingers. So I mean, it didn't really apply in this case. I suppose it could, especially when we look at what people are doing to make zooming and flicking better, right? You may have noticed on your phone, if you flick your finger really fast, it's called a fast flick or fling or whatever. And there's like a ratio that determines how fast you flicked it compared to how far it will go. So developers are already kind of looking at that. That's, I think, kind of getting into the gain that you get from like the mouse. You mentioned earlier how it's designed. You move it 1 inch and it moves 10 inches on the screen. I think they're accommodating on touchscreens for those with these kind of gestures where if you do it fast or with a lot of pressure. So, I mean, I think it definitely applies to it. It was beyond the scope of our research, though. Any other questions?
I'm just curious about your effort scale, like with the pinch and zoom particularly. I've always seen it as kind of a shoot and then refine type method where like you have your out and then you go in and it's still part of the same thing.
Mm-hmm.
How does that like really compare when you're talking about something like maybe you hit the button 10 times? Is that effort?
So with the effort of all the tasks, the effort is different, right? The minimal effort wasn't measured by how many times they'd have to zoom in like this. It was measured by how far they have to stretch their fingers with the operating system's calculation for zooming. You see what I'm saying? So it wasn't how many times, it was just how far of a spread that had to occur in order for it to be zoomed in to the maximum ability. It didn't really matter how many times they did it, it was just the spread had to be the right, or they had to spread a few times to make it the length.
But if I was understanding correctly, you were measuring it by how much they like overshot their targets.
Yes, so it's effort exceeded of what is optimal according to the task. So each task had its own optimal measurement of what was optimal, and then the effort that we recorded was the effort that exceeded what was optimal. One more question.
Yeah, so I was wondering if you could comment on, you kind of have like a high productivity task, right? They're flicking through a lot of stuff. Yeah, traditionally when someone's using something like a tablet or a cell phone, they tend to be less productive tasks. And so you're making these recommendations for things like pension and swipe, or let's talk about swipe, when in reality I'm only going to be doing it once or twice, and then maybe on my cell phone I have more screen space, like that tends to be maybe a higher priority. Like, can you comment on that?
Well, I don't know. I mean, I tend to find that on Facebook or on my contacts on my phone, I'm flicking a lot. You know, it's certainly more than once or twice for me, but that kind of gets into the recommendations that we have from the study to consider the task of what you're doing and then the method of how you implement it, right? Like buttons maybe don't make sense if you are just flicking once or twice, right? But if it's a lot of content, say some kind of medical device where you're going through heart rate patterns and you need to go through a lot of history, flicking maybe is not the best or most ideal method for doing that. I don't know if that gives you anything. All right.